Excellent.
I started those.
Okay, so we're just making sure that we can record. Okay, sweet. It already says recording, so it looks like it propagated. Okay, so thank you to the 7 or 8 of you who are game enough to attend our first discussion section that's virtual. Today, we're going to do a couple of things. So the problems that we have are just a couple of pretty straightforward review of strong duality, which basically everything you'll see today was covered in lecture. So, you know, our main purpose of today is really prototyping all these Zoom tools, seeing what's going to work going forward, because we don't really want this, you know, discussion section to just turn into another lecture, because that's not really the point of a discussion, but we are, you know, limited by our tools. And so we're going to take a little bit of time, slow down a little bit, and just see which of these tools are actually useful. And so we're going to be relying on you guys to be giving us feedback during and after this session. So in particular, for this session to work, each of you right now, you can see the iPad that has you know, the different problems from this discussion section, but go ahead and make sure that you have a copy of that handout locally on your own machine, because we're going to be trying something today called breakout rooms. That will basically we'll be splitting you into groups and seeing if we can facilitate a little bit of group work, and you guys can give us feedback on whether or not that works at all. But one thing that happens is that you then lose access when we put you in breakout rooms. You lose access to everything that we're streaming. You know, we're working on that, but that's a limitation of the tool. So just make sure you have your own copy of the questions so that when you're discussing, you have something to use there. In addition to that, those of you who do have tablets, it would be great if you could do some like prototype screen sharing of your own. Like when we go into breakout sessions, and report back to us on whether that works or not, or whether there are ways in which we don't understand this tool yet. But if you don't have a tablet, it's completely ridiculous to expect that everyone has a tablet. You know, work on prototyping other ways that you might, you know, even if it's just holding up a piece of paper in front of your webcam, see if that works. And whether that's effective for communicating math. We're all kind of learning together here. So in particular, I think the tool, I want to do a brief list of the tools that we're actually going to look at today. So the first is just Zoom in general. So we're learning all of these tools together. The second is this whiteboard iPad. And in particular, I'm listing these because I want you to be thinking about them as we do this discussion section so that you can report back on which pieces of it were effective or were not effective. We also have the sort of hand raising / chat window that Vignesh, who's here with me, will be monitoring. So if you can, and also Vignesh, if you can let people in from the waiting room, I think there might be somebody there. I might have to do that. Are you allowed to manage participants? I can do it. I can admit all.
Yeah, I can admit that.
You cannot?
I can.
Okay, you can. Sweet. Okay. So we have this hand raising chat window that should allow you to give us sort of click-based feedback, and Vignesh, who's here, will be monitoring that. And so we can stop from time to time and service that queue. We're kind of figuring out how we're going to be modulating between these different tools. And then the last thing, or well, 2 things, breakout rooms, which I mentioned. Some of you may have already used these in other classes. These are for basically splitting you all into smaller groups in which you can discuss things. That's something that we don't know if it's going to work yet, but we'd like to try it today, even though these problems are fairly simple. And then lastly, as we mentioned, this session is being recorded. So for the benefit of people who can't attend these times, if that doesn't, but we're still figuring out exactly when we press record what that means, whether that means it's recording the iPad, my face, your face, we're still figuring all of that out. And so in particular today, and probably going forward, we're definitely going to have a section of this session at the end in which we will stop the recording and just have an open discussion about how things went. And also, you'll notice on the agenda today, just kind of a life check-in to see how everybody's doing, because I know, you know, this whole situation has hit me personally like a freight train. I'm worried about my family. I know you guys are worried about your families too, and things like that. And so we just want to have, and it's, you know, with everyone remote, it's really hard to get a sense of how our students are feeling. We forced a midterm on you yesterday. And so it would be great to have, you know, as candid a conversation as we can once that recording has wrapped up. So I think that's kind of the agenda for today. Please bear with me. This is Vignesh's iPad. I've never really used these tools before, so we will see how this goes. I figured out how to make text smaller, so that's the first step. But before we get into the actual math here, are there any questions from any of you? Feel free to, when you join by default, your mic is muted. There are few enough of you that I don't think it's going to be a free-for-all if people just try to talk. So at this point, just feel free to unmute yourself and say something if you want when I call for questions. If that gets too crazy, then we'll implement some sort of a hand-raising system. But before we move on, does anybody have any logistical questions? And if there's no questions, feel free to like put something in the chat just so that we know that you exist. Okay, no questions, no chats. Excellent, no feedback. Okay, all right. So I guess with that, I will move on to the actual substantive content insofar as it exists for this session. So today, as I mentioned, we're going to be talking through a couple of examples of strong duality that are very similar or identical to what you've already seen in lecture, but just as sort of a quick review of some of these kinds of tools that you'll have to use over and over again later. So it is useful. If you do find today challenging, then definitely, do that review. I know this stuff wasn't on the midterm, so maybe you haven't looked at it at all yet. So maybe this is a good chance to get up to date on that. So for this first problem, which is a simple example of strong duality, basically we're looking at a minimization over a scalar quadratic x squared, subject to that x is greater than or equal to some epsilon, which we haven't defined yet. So for part A, we're just asked to solve this optimization problem for P star directly. So just solve the primal problem. So I think we will, just to give you a couple minutes and try out breakout sessions, I'd like to break you out into a couple of smaller groups. If you guys could talk amongst yourselves, converge on an answer for this problem, I will then, Vignesh and I can pop in and out of those sessions, and we can reconvene, and I may ask one of you to attempt to share, oh look, news stories, may attempt to share your suggestion via, so nominate someone from your group to share an answer once you come up with one. So I'm gonna click breakout rooms and see how this works. Assign 11 participants into, let's see, let's do 3 rooms, create rooms. Okay. All right. So you should have all received an invitation to join a breakout room. Please respond in the chat if you're having any trouble existing in a breakout room. Okay. All right. And it looks like one of you here.
So why is that I can only join breakout room 2?
Because you were assigned, because you're a participant. Okay.
Probably there should be some way.
Yeah, I need to put someone, how do I put him assigned to breakout room 2? Okay. So now there's at least 2 students in each breakout room, but both of them just left breakout room 2.
Probably because no one else was there.
Yeah, probably because no one else was there. Okay, so we found our first bug.
Mm-hmm.
Okay. All right, so one of them is back.
How do I join a breakout room?
So if you click on breakout rooms.
I want to join, let's say, breakout room 1. Can you join breakout room 1?
Yes, I can join breakout room 1. Okay. Can you join breakout room?
I can only join breakout room 2.
Okay.
Because you assigned me that. Can you not assign me that?
I can move you. Okay, I'm just gonna move the 2 people.
I see.
So I'll move you to breakout room. It doesn't matter. I'll move the breakout room 1, breakout room 3. Okay.
Okay.
All right. Okay, sweet.
They
All
probably
right.
can't hear me because
Because you're muted.
yeah.
Okay. Which room did you join?
3.
3? Okay, I'm gonna join 1 and see how it's going.
Yeah, I'm afraid to unmute the mic because we have infinite echoes
Yeah.
for sure.
It's true. Whoa, okay. All right. Hello, breakout room 1. Can you hear me? Okay, can you hear me? Yeah. Okay, sweet. I couldn't hear you because I have 2 different Zoom windows and I realized the right one wasn't on yet. Okay, so yeah, how's it going in here?
We started talking about it.
Okay, great. Yeah, and I can see whoever's got the camera on their notebook. That actually looks totally fine. Okay, great. And it looks like you guys have have the answer to A down. Are you moving on to B? I see.
I want to, or we had just been talking about, Charlie was saying that he had not made it conditional. So I thought we would talk a little bit about that before we move on.
Okay, sure. Sounds like you guys are doing great. I think we'll reconvene in a minute or 2. I'll pop in on the other group and see how it's going. Okay, great.
There's no response in this breakout room.
There's no what? Oh, in the second breakout room? Is it because your sound is muted?
I mean, like, no one's mic is unmuted.
Okay. All right, let's see what's up with breakout room 2.
No one is like chatting. Breakout room 3.
Okay. Okay. I'll put the next person in breakout room 3. I also see Alex. Hi, Alex. You aren't in a breakout room. Why aren't you in a breakout?
Breakout room concept is.
Okay, I put someone else in breakout room 3 as well. Okay. Okay. Yeah. Okay. Hey, Alex, can you hear us? I'm trying to put you in a breakout room so that you can work with other people, but I'm not sure why you're not showing up. Breakout rooms. Sorry, what'd you say, Alex? Sorry, Alex, we're having technical issues. Could you type in the chat whatever you're trying to tell me?
Okay, I know the problem.
I'm sorry.
You can't unmute your mic.
I can't unmute my mic because of
you can,
feedback.
but mute this first.
Okay. All right, I see a chat. I'm here. Okay.
Hello?
Laura, I think you're muted right now.
I can't hear anything. Yeah, I can't hear Laura. I'm thinking another breakout room or
Oh, I suppose it's a possibility. Yeah, maybe Laura is not back in the main room yet. Okay, Vignesh is unmuted, so.
Okay. Can you hear me?
Yeah.
Okay. So I think the challenges that we're having are related to trying to turn on 3 sets of mics and three sets of mics and 3 sets of audio on our own machines so that we can hear you guys, but we don't create screechy auditory feedback. So that's something we need to prototype more. I think everyone, the breakout rooms should be closed now, so all of you should be back. I guess maybe, I guess if you're not back, then I won't know.
I think everyone's back.
Okay, but it seems like everyone is back. Okay, great. So does someone from, let's see, I know I stepped into breakout room 1 and you guys seem to be collaborating really well. Does one of you want to try to share your answer to the first part via sharing a video or your audio? So that would be, let's see, it was Moses and Jayu. Does one of you guys want to contribute an answer for part A?
Oh, yes. We talk about the, so for part A, the solution will be if the E is bigger than 0, then it would be just the E square. Otherwise, it would be 0.
Okay. And could we prototype just like you sharing a video about that? I don't know.
Yeah, because I using my iPad, but I using my MacBook to use, so I don't know how to sweep that.
Okay, so that's something to keep in mind. Yeah, I think we might be stuck. So for those of you, I think this is going to be hard because math is kind of inherently visual. So I will draw out the solution for now. But basically, we're talking about minimizing over a quadratic. And so if we have x, and then we have f of x, which is x squared, we have some sort of a quadratic, and well, we have x squared, right? Which looks like this, if I can draw. That should be 0. So if epsilon is, so I think what Moses or Jayu was saying, I can't actually tell, is that, so if epsilon is, so we require that x is greater than epsilon. So if epsilon is less than 0, so if epsilon is over here, actually, I'll use a different color. So if epsilon is over here, then we have the whole, we have basically this whole side is in our feasible set. And so we know that we can minimize this function at x equals 0. So we have p star equals, so if epsilon is less than 0, we have p star equals 0. And alternatively, if we have epsilon is greater than 0, then our feasible set is only this side, which means that basically our x star will be exactly epsilon, and so our p star will be epsilon squared for epsilon less than or equal to 0.
Greater than equal.
Or yeah, good call. Greater than equal to, whoops. Greater than or equal to 0. Okay, cool. All right, should be fairly straightforward on the math side, even if the technology is not straightforward. Does anyone have any questions? If so, please mark that in the chat thread. Okay, great. So for this next part, I think we can, let's see. I'll go through a couple more problems to kind of calibrate us on the iPad, and then we can break out into groups, breakouts again when we get to part D, just to get the give you guys another shot at that and prototype that one more time. Okay, so for the second part, we have the Lagrangian function L of x lambda. So in this case, we'll need to do a couple of things. So by sort of the definition, what we have is x squared, which was our original f of x, plus lambda times, we need to do a little bit to this constraint. So right now we have our constraint is x greater than or equal to epsilon, which is equivalent to epsilon minus x is less than or equal to 0. Remember that we want our constraints basically in our inequality constraints always set less than or equal to 0, so that when we eventually try to maximize over lambda, everything works out properly. So in this case, we will have plus lambda times epsilon minus x. Okay, so that's going to be our solution for that second part. This next part will just be the dual function. So we have g of lambda, which we, if you remember, define as the minimum over x of L of x lambda. Let's make that a little bit smaller, which is equivalent to min over x of x squared plus lambda epsilon minus x, which we can let's see. So what do you notice about this function? How should we minimize this function? Is it constrained?
It's not constrained, and it seems to be convex, so we can look at where the gradient's 0.
Good. So let's see, didn't leave myself quite enough space here, but that's exactly right. So this is an unconstrained convex function. Unconstrained. So we can use our gradient tool to solve this problem. So if we have delta of, oh wow, this went crazy because I made this small and I shouldn't have. Okay, that's okay. L of x lambda, which is equal to let me make sure I get this right. 2x minus lambda, right? Yes, equals 0. So then we have, and this occurs at x star. So then we have x star is equal to lambda over 2. So when we, here, I will get rid of this section. And so we have x star equal to lambda over 2. Big Nash is laughing at me over here. Okay, and that gives us g of lambda is equal to lambda over 2 squared plus lambda epsilon plus or minus lambda over
lambda squared by 2.
Yeah, lambda squared over 2. Okay, and all of that is equal to negative lambda squared over 4 plus lambda e. Okay, all right, so that is our definition for part D. Note for later, make there be more space in each problem. Apologize in advance to all of you. Okay, all right. Okay, any questions about that problem? Okay, I'm relying on the chat rooms, so and on your verbal feedback. Okay, great. All right, so for part D, you're asked to solve the dual problem. I'm going to break you guys out into breakout rooms again. I know, so it seems like breakout room 1 got some traction, had a video of their of everything going. For those of you who are in breakout room, I think 3, which may now be 2, I'm not sure. I'm actually going to because people have arrived, I'm going to reorganize some of these breakout rooms again. But for those of you, we will make sure that there's at least like 2 or 3 people in each room. So if those of you who are there could unmute yourselves and engage so that we can try this, that would be great. So I'm going to recreate some breakout rooms and you guys can take a look at part D.
Just make 2 rooms.
Okay.
Like 6 people.
Okay. Yeah, looks like there should be. All right. Okay, cool. So it looks like everybody joined. Do you want to join either one?
I'm in one, but I can't talk because of course.
Oh, because of, okay, so you're in the first one. Okay, that's fine. They can probably hear, well, I don't know.
Yeah, they can. I can hear them.
Okay, I'll join the second one then. But it's true that I can't. Maybe, I guess I need my own headphones too. I guess that'll solve this problem. I get a funny echo of myself, but that's okay. All right, I will join breakout room 2. All right, hey guys, how's it going in here? I notice all of you are muted and all of you have no video. So I think you're all lurking. All right, I see one unmuted. How's it going in here? Hey. So I can hear you. So I think you're not. Okay. You got me? Okay, sweet. Yeah, so I think it's because for the main room, we have the audio on the iPad and this one is just me. Okay. All right, working out the kinks. Okay, great. So I noticed you're the only unmuted human in this room. Have your friends said anything to you yet? Oh, okay, that makes sense. Okay, that's something to keep in mind. Okay, great. So are you guys collaborating via chat then? Okay. Yeah, one of the limitations actually of these breakout rooms is that I can only see the chat as soon as, like, I can't see all the chats that have already happened if I open chat. Okay, good to know. How are you guys getting on with this problem? Okay, sounds good. Okay, so I will leave you guys do it and check in on the other group. All right. Okay. Did you check in on the other group? Seems like they're working together. Okay. Okay, and I'm gonna broadcast a message to all. We'll reconvene in 2 minutes. Other tools, so.
Yeah, so
Okay, close all rooms.
these breakout room got it.
Okay. All right. So yeah, breakout rooms will close in 60 seconds. All right. All right. Some of you are back. Breakout room 2, I think, is. All right. All coming back. All right. One student yet to return. So interesting. Okay. All right. Since most of you are back in the main room, I think we'll go ahead and get Okay, now all of you are back in the meeting room. Great. We'll go ahead and get started. Okay, so does, I think I hear through the grapevine that you guys have made some progress or finished this out. So I think, does anyone want to raise their hand and give an answer here? Or would you guys prefer that I just write out a solution for now? I guess Vignesh is monitoring chat over here.
I think I'd like to, I don't know if my screen share is visible, but.
Okay, sure. I see your face, not your screen share,
Okay.
but we can, if you'd like to try it, it would be great to try a student screen share.
All right. Is there a way to, oh, okay, wait, is this now visible?
Okay, great.
All right. Is the image inverted?
So the image is really small. So I think for those of you following along, if you go to Moses' screen, I think you might have to, okay, you might have to click on his screen and click a checkbox. It's not inverted. It looks fine.
Okay.
But you may, for other students, you may have to go ahead and click on that that window in order to make it appear fully. Okay, great. But it looks like we have a good solution here. Okay, you want to talk us through it?
Yeah. So first thing I did was take a look at like first derivative condition. So it's a quadratic, so it'll have some peak. So if we're not constrained, then we can choose lambda equals 2 eta. But then I thought about, okay, well, depending on the sign of eta, then it might be the case that that peak is not in the feasible region. So I was plotting it out to check what it looks like. The zeros are located at lambda equals 0 and lambda equals 4 eta. So if eta is negative, then we get a graph that looks like this, where the 0 occurs somewhere on for values of negative lambda. So it's this, the maximum to this is also conditional, where if eta, sorry, not eta, epsilon. If epsilon is less than or equal to 0, then the best we can do is have a maximum of 0 at the origin. And if epsilon is greater than 0, then we can actually hit the peak at 2 epsilon. And oh wait, hold on. Let's see. I don't know that this is maybe what lambda star is, but not evaluated.
Yes, so yes, and in order to get that, so you'll notice that parts D and E actually asks you for that lambda. I don't really know why it was presented in that order, because I solved it basically the same way that you just did. So yes, that's lambda. So that's actually the answer to part E. Okay. So to get D star, you just plug that back in, right? Right. And so, yes. Okay. Great. Right, so it ultimately ends up being epsilon squared, right? Mm-hmm. 2 epsilon squared minus epsilon squared. Okay, great. I don't think I need to, I think you did a great job showing that solution. Do people have questions? I think depending on your streaming resolution, some people might be having issues. Please let us know if that's the case, if you just can't read the text, or if you do have a question. I think I'm not gonna, the solutions will be out in a sort of more clean format, but I don't think I'm gonna take the time to write out what Moses just wrote out pretty beautifully. So any other questions about this problem? Okay, all right, cool. So I think for the second part of this problem, you know what, we're at 144. I think, as I mentioned, both of these problems are things that we saw in lecture, and so I don't actually feel the need to go through problem number 2. You guys are welcome to ask me to do that, but I think I want to move on to just, I'm going to turn off the recording and do a general discussion of how things have been going for you guys, both in terms of this class and just in terms of like the broader Berkeley experience right now. So before we shut off recording and chat about that stuff, does anyone have any last academic questions that will be recorded? Either, you know, feel free to do it in chat, or to unmute your microphone and say something. Okay, sweet. All right, so what I'm gonna do right now is I'm gonna press the stop recording button. All right, bye everyone. Yes, I would like